And we are live again. Welcome back to our Kotlin YouTube channel for the Kotlin for the server side webinar series. It's the fourth episode already. We had a few other episodes with Justin Lee about Quarkus, with Nicola Frankel about Spring MVC and migrating to reactive. And we also had the first session with Alexei from Cuba platform about JPA with Kotlin. So today we are going to talk about a very nice, I would say, very nice framework, which is actually a Kotlin native framework and implemented in Kotlin. And we have two folks who are actually the authors of the framework, right? We're going to bring in David and Ivan right now. To stream. Hello, folks.
Hello.
How are you doing?
Pretty good.
Nice. So today we are going to learn about this micro framework. I have tried playing with it. I didn't really have time to actually implement like a demo application, but I was going through the wizard, the project generator, and it was pretty slick. So today we are going to use this framework for a demo, and I guess there will be a very nice demo. For the folks online, please shoot your questions in the chat as usual. I'm monitoring the chat. I will be in the background. I will leave David and Ivan online, and I will be monitoring the chat and try to answer the questions. If needed, I will probably jump in, make a break and ask questions if it's really needed, if I feel so, but I don't think we should be doing it this time. Maybe we'll leave the questions till the end, right? So the floor is yours, David, Ivan. You can proceed.
Okay.
Right. So the way we decide to run this today is we're going to do a quick presentation. We should introduce what HTTP4k is in around 5 minutes, and then we're going to try to code one application live here. So wish us luck. So HTTP4k, let's talk about the Swiss Army knife for Kotlin HTTP apps. Next slide, Dave.
Yes, I would if I could. Okay.
Okay, cool. So what is HTTP4k? Is very different from your usual web framework. We try to call it more as a toolkit for building HTTP-based applications. Like it was said, it was built natively in Kotlin. It has a bit over 4 years, almost 5 years old now, and is mostly based on functional concepts and try to favor composition and immutability on its core. It also very different from a lot of other frameworks in the sense of we went in the direction of trying to minimize the magic. We try to have absolutely no reflection, no annotation, no general magic that will make things more complicated internally. And so far that has paid off. There's a lot of things that we can do very easily now because of that kind of decision. And we also, part of that is trying to minimize dependencies. So our core, you can basically start creating client using client HTTP client applications and create servers with no dependencies, just using Java and HTTP4k. Also, we are quite heavy on the test-driven approach, so we're trying to minimize the amount of extra work needed for testing. So we're going to cover a bit of that later as well in our demo. So we can summarize HTTP4k in only 3 concepts. And those are, first, the idea of an HTTP message, which is your usual request and response. In our case, they are simple data classes. We have a bit of syntactic sugar to make it nice to add queries and headers and body and so on. But they are just plain immutable data classes from Kotlin. So here you have an example of a request and response there. The second concept, which is probably the most important, is the idea of an HTTP handler. And that's just a type alias for a function that takes a request, returns a response. So, and as an example, you receive the request. And in that case, we're just doing an echo by returning a response with the same body that you got in the request. And finally, the main concept that we have for the kind of middleware that people would expect is the idea of filter. So a filter takes an HTTP handler and returns another HTTP handler, allow you to add cross-cutting functionality on your application. So in that case, we have an example of a filter that will remove a particular header. So that basically applies to any HTTP handler that you have and creates a new HTTP handler with some added functionality that can be used for all sorts of interesting things and keep everything decoupled from your main application handlers. Yeah. So the main power I think we have with this approach of HP4k is that everything is just composing functions. And the main function that we described, the HTTP handler, is used as a uniform interface both for client and server. So that means that when you create an endpoint in your application, what you're creating is an HTTP handler. When you're creating a server, what you're creating is an HTTP handler. A client is also an HTTP handler. So if you look at the puzzle piece, all the bits that connect to each other, they look the same. So it's easy to replace a client with the server or vice versa. If you want to add some test server instead of a client, you can do that kind of thing as well, which unlocks a lot of extra functionality that becomes really easy to implement. And we're going to try to show a bit of that in the demo. So these, what does that mean? This kind of uniform interface for HP4k, it goes back to the core of what this toolkit is about. So it keeps it lightweight with those concepts only. It's still heavily composable. So every module that we have in HP4k is just normally dozens or 100 lines of code. Nothing is too big, and you can just keep adding new functionality in a very isolated way. Everything is very pure in terms of functional. You can just invoke an HTTP server by calling a function. You can't get much simpler than that. And also that ends up being very good for testing. So we are quite keen on test-driven development. And we found that HP4k allows to do things that are very hard in using other tools. So the simplest case is that servers and clients can be interchanged. It's also very easy to create your own fake servers to replace existing functionality that you get from third party. We also, by only using very basic concepts, it means that we don't need our own test runner or test framework or anything. You can just pick whatever you already use and just start applying straight away. And we also allow people to create tests that will be portable across the test pyramid. So we see quite a lot. You can create a test with an HTTP handler and you can run that in memory without using any server, without network. But then you can apply the same test and start touching network, or you can run the same test against a fully deployed environment. And the test becomes more portable that way with this approach. Yeah. So like we said, the framework has now around like 5 years and a lot of contributions happened so far. So we support quite a lot of tools that are familiar for people's ecosystems in terms of formats in JSON, XML, YAML, Open API, spec. We're doing a lot of things in serverless these days. Don't know what else, Dave, you think is like worth?
I think that so I think the most important thing is that there's, I think we're up to 17 deployment platforms now, including 6 different serverless platforms. The main point is that they're all really easy to swap in and out. So that because of this consistent kind of abstraction model, you will see that in a bit in the demo.
Yeah, hopefully, they'll become clear when we start showing that in the demo. So should we talk about this demo, Dave?
Yeah. Okay. Right. Okay. So what we're going to build. So we're going to build an API kind of proxy to the PokerCo API, which is like an open Pokemon dictionary, I suppose you call it, or database. We're going to implement a single endpoint, but we're going to do it backwards. So we're going to do it slightly different to what you may expect. We're going to start with the API at the back. We're going to kind of push the information we're going to push the information flow forward towards the client. We're going to try and keep everything running all the time without any breaks. and hopefully, in terms of kind of when it's going to naturally flow from step to step, hopefully, because I'm doing it live, from step to step to step. And the endpoint that we're going to be talking about at the end is this API endpoint at the bottom. Okay, right. So that is what we're going to do. We're going to do that initially by, the first thing we're going to do is going to go to the toolbox. So this is the HP4k Toolbox, which we built for people to use. And this is basically it's kind of a collection of things that we've found useful and decided to automate in order to kind of develop our API applications. And we'll see most of them today. But so the first one, obviously, is the Project Wizard. But let's go through that. I'll just go through this in a bit. So you can also, the Project Wizard, this thing is also available via Toolbox CLI, so you can install it via Brew, etc., or SDK Man. And we've got stuff like IntelliJ support with live templates and stuff. So we're quite heavy IDE users. Hope you'll see that as well. We've got lots of little kind of shortcuts that allow you to do things quite quickly with HP4k. Cool. So let's initially do our Project Wizard. Right. So this basically is going to allow us to generate a fully formed project that will, it will basically include build and testing and whatever. And this covers all of the 50 modules. Basically, every single thing in here is is represented. So, Yvonne, are you going to talk me through what we're going to do here in terms of generating projects?
Yeah. We're going to need some server. This project, the basic one, won't be serverless, so we just choose one server for now.
Okay.
We're not going to do WebSocket and server-side event. We're going to show that later if we have time. Which server we're going to pick up? Undertow, I think, is our tool of choice nowadays.
Okay.
For client, we can keep just with the Java one. We don't need anything more fancy than that. For format, let's use Moshi for JSON. No template, nothing more complicated in terms of formats. Yeah, no OAuth, no AWS. Let's start very simple for this. Yeah, nothing specific for testing.
Okay.
And we can call
hello HP4k.
hello. Yeah.
Right. Okay. Next. And this is Gradle. So we want Gradle.
Yeah.
Zip file.
Zip file is fine.
Perfect. Okay. Right. So yeah. So at the end here, you can get a preview. This is kind of pretty standard stuff. Allows us to see exactly what we're going to download, and then we can download the thing. There we go.
Yeah.
There's also a useful thing to kind of you can copy the URL to then use it again and again and again to generate the same project. Okay. Right.
Yep.
Let's get cracking. Okay, so let's do some coding. Okay, so this is basically a hello HP4k here is basically what we would have got if you would have extracted that zip file I just downloaded, but we've put it inside an IDE. It does come completely prepared. What you would get is this kind of subfolder here with the Gradle module and Gradle file, etc. So everything's that would be completely importable from the spot. Okay, Yvonne's going to tell me what to do because we're going to pair.
Yes, so we're going to start by cleaning up some things. So let's start with the test. Because of time constraints, we're not going to do this fully test-driven. So we're happy to delete the tests that come with the wizard. And we're going to show tests, and we're going to have source code available with the tests for people to check out. We can also delete pretty much everything. Let's leave the main function empty. Yeah. And yeah. Yeah, that's exactly what we expect, which is nothing. And let's start by creating a Java HTTP client. So that's going to be our main tool to start playing with the PokeCo API. Let's put that into a variable. Yeah, call HTTP. Yeah, and the way we mentioned earlier, calling HTTP is basically calling a function. So let's call HTTP with a request, a GET request in this case, and the URL. I think Dave may have like some, so this is the URL we're going to get. We also need to add a query parameter so we don't get too many results. So let's do a query of limit of 100. So we're going to get 100 results. And that's enough to call and run the server. So like if you run this, we can't see anything, but trust us, like we did call through the network and we did invoke that server. So I think what it'd probably be useful is to actually know what we did, what we actually call. So let's do that by adding a filter. So we can show what a filter looks like. Let's create a debug filter. Yeah, and we have like these live templates. So a filter in that case, the signature there, next is your next handler in the chain. And we have the request. That's the request that we pass around. And what we want in this case, just to see that we're really invoking that server. After we call next, we have a response. So we can do .also, and then we should have a response at that stage. And we can just print it. So you can do response print line. Yeah. And that's our filter. And this filter should apply to any HTTP handler. It will print all the responses. So let's apply that filter to our Java HTTP client. So yeah, the Java HTTP client, it is an HTTP handler, so we can just do debug then HTTP handler. So calling that again. And now we have some results as we expected. It's printing the whole response. So I think if you go to the top, you can see pretty much what you expect from curl, like HTTP 200, all the headers, and then the body after that. So we can bear that in mind. And next, I think what we can do is we're going to try to use a bit of a trick that we tend to do, which is we don't try to develop everything running against a real third-party system. So what we're going to do is right now we have a client, and we're going to try to replace that client with a fake version of the PokeCo API. But before we do that, we can use another handy filter in this case, which is called setBaseURI_from. And if you do inside it, then before the Java HTTP client, Dave, if you do client filters, filters dot setBaseURI_from, and we can, URI off. And the URI in this case, let's get the host from that request that we have there, just the host part. Yeah, and then Java HTTP client. I think you're missing a bracket at the end.
Bracket there.
Yeah, and then we can remove the host from the other one. So what this does is like it's quite common for us that we want to decouple setting the host from calling different URLs on the same host. So in this case, did you just run? You run again.
Yeah, just run it.
Everything runs fine. We can also move before we start cluttering too much our solution. We can move the debug filter to its own file as well. Yeah. So that setBaseURI and a real, there's some import. Yeah.
The wriggle IntelliJ, sorry. Yeah. I knew it was coming.
So these setting the base URI and having a real HTTP client is all we need in order to call a real PokeCo. So let's extract that to a function we can call real PokeCo API. Yeah. And we can potentially move it to its own file as well. We're not going to touch this because the way we call the real thing won't change. But we can try to see how would a fake look like. So the way we can start doing a fake implementation is instead of that, we can replace that real PokeCo API with the empty HTTP handler. So yeah, that's another live template that creates the basic signature of an HTTP handler function. And what we're going to do for that, let's call that our fake. Let's extract that because that's going to be our fake PokeCo API. Yeah. So far, this is a handler that just returns OK. So it's definitely not behaving anywhere near what the real API does. But we're going to change that straight away. So let's move it to its own file so we can extend. And now we're going to show one trick to get exactly this fake getting exactly the same response as the real one. So we can copy the response from the output. Because that response that you see in the console is the raw response that is sent through the wire. So that's pretty much standard HTTP. And we can use that to generate some code. Dave's going to do that for us.
Yeah. Do that. There we go. Okay, so yeah, when we're back to this, the toolbox again, this was another example of something we found really handy, which is basically we want to do something with an HTTP call and we want to basically make it into a code. So we can generate our code directly from our thing and it'll build our HP4k objects from that. And we copy that.
Yeah.
And put that back into here, and that goes into here.
Yeah, maybe there's some
it
imports.
basically- Yeah, response. Yeah, probably. So look, yeah.
Yeah, I think he puts the package again.
Okay, fine, no problem. And then just inline that. There we go.
Yeah, so now our fake is just a local version of that response. That's all in memory. Usually you can clean up, you can use test data. You probably don't need the headers. But the idea is, because messages are just data classes, you can build your own very easily, and you can just pass them around through the HTTP handler function. So can we run it again, just to make sure that...
Yeah. There we go.
Cool. So we're running now the same server, but we're not touching HTTP, the real PokeCo API. So at this point, you can basically go offline and still work on HTTP in your application. So at this stage, we want to start adding a bit more logic to this PokeCo API. So maybe we can extract this whole, the whole stack that we have there, which is the debugger and the client and the handler for the URL, and we can extract that to our PokeCo client. Yes, and the PokeCo client, now we can turn that into, is going to be our application, our Pokemon 4K. No, the Pokemon, yeah, on line 10, sorry.
Okay.
Yeah.
You sure? I don't think so. I think it's this.
Yeah, let's start with that. We just need to create our own server at this stage and pass that around.
Yeah, it's this guy.
Yeah.
Yeah.
So I suggest the fake PokeCo API, we pass that as a parameter.
Okay.
Yeah. Because that's our dependency. Yeah. And that's an HTTP handler. So, yeah.
Right.
PokeCo.
There you go.
So what we have now, line 10 is still our client. No, it's not.
He's our
That's
app.
fine. Yeah, so we have our app and we have our client. You can inline that if you want.
We're turning this into a server.
Yes. So what we can do at this stage is the Pokemon 4K is going to be our server. So we do have a client and we can just start to run it. And the way to run that is like you get any HTTP handler and you just say as server. In this case, we're doing Sun HTTP. And for HTTP, in this case, to call it, we create another Java HTTP client. Yeah. The difference now is because we want to call the server that is on port 8000. Yeah. We need to actually put the host now in our request. Yeah.
Actually.
Yeah, and we can do with the app.prefix port. Yeah, and we can put port 0. So this is another trick that most backends allow you to do, is that if you put port 0, you can refer to that.
Okay, interesting. What's going on? Oh, wait a sec. Too many things.
Yeah, too many brackets there.
Too many brackets. There you go.
Okay, so what we have now is we have our client that's being injected into our server, and we can start our server locally. So now we go back to, we're getting an HTTP handler and we're running that in the network. We can continue to develop without network, but for now, it doesn't make a lot of difference anyway. So we're going to continue using localhost. But we also have to remember that when we're doing the wizard, we talked about, well, maybe we should use Undertow. So let's show how it is to replace Sun HTTP with Undertow. Yeah. And that's it. So now we run, if you want to run with Jetty or some other server or Apache, you can just change the same way. So from the initial picture of what we want to build, we do have the main pieces at the moment. Like we have HTTP, which is our client. He calls our Pokemon 4K, which is our own server. But this server, the only thing it's doing is proxying the request to the PokeCo API. So I think now it's probably good if we start evolve a bit more to have our own client and our own abstractions in the Pokemon 4K server. So the way we can do that is we're gonna get the PokeCo HTTP online 18.
18. Oh yeah, this guy. Yeah.
Yeah.
Sorry.
Yeah, at the end there.
Oh, this guy.
Yeah, and we're gonna wrap that with its own. Yeah. So this is exactly the same thing. We can just call PokeCo request. So this is equivalent. We just get in the request and pass through the client, and that's all fine. But now, if you want to add our own types there, we might as well create a client. So that request that we done there, we could probably use having our own Pokemon client abstraction, which we tend to use as a class, not as a function. So I don't know, Dave, if you want to
build a class.
Build a class for us. Let's call that the Pokemon client. Pokemon client.
There we go.
Yeah, also receives a handler.
Okay, yeah, that's it. There we go.
Yeah. Yeah,
cool.
And we can do a function to list our Pokemons there. Yeah, and the only thing it does is it needs to call our HTTP handler with exactly that request that we have on line 15. Yeah, we can clean up that. Yeah, yeah, we can clean that up.
There we go. What am I doing with this?
Yeah, so we can apply that client on line 18. Let's create that.
18.
Oh, yeah.
What I'm going to make a new thing.
Yeah, that's fine.
HTTP handler.
With the PokeCo, yeah, just pass the PokeCo. Yeah.
There we go. And this is what am I doing here? .list.
And just return .list.
There we go.
Yeah. So this we starting to add our abstraction of a Pokemon client. Is still just forwarding the response for the sake of simplicity. But what we've done now is we detached the client that we invoke inside our server from callings to our server directly. So if you go to line 15, you probably don't need all that path and all that thing. Yeah. Oh, yeah.
There we go.
Cool. So everything still remains the same, but now we detach, like there is a route that goes to our server, and our server will call the PokeCo client independently. Right, so the Pokemon client at the moment is only calling a request and sending a response. So should we move it to its own file as well?
Yeah, let's
try to keep just one thing. And the Pokemon client, usually, if you're going to do something a bit interesting, you're not just going to be passing request and response around your application. So you do need to, at some point, convert to your own types and try to have your own abstraction so you can actually put some logic in it. So what we're going to do in this case is we're going to introduce the concept of lens, which is what we tend to use for this kind of operation. Dave, do you want to run that part?
Yeah, okay, right. Okay, so what is a lens? So a lens is effectively, everyone see that? Cool, brilliant. So a lens in HP4k is another function type. Well, it's actually not one function type. It's kind of two function types. And the two different types are called inject and extract. And they're modeled directly as Kotlin function types, so they're just invokes. Basically, so what a lens does is takes two types. It takes an input type and an output type. The input type, and what the idea of the lens is the injection takes a oh, actually, this is the wrong way around. Damn. But anyway, so the injection takes is actually this one. No, okay, so is it that one? Yeah, sorry, yeah. So this is the wrong way around. Damn. Let me just put this in the right thing. Sorry, apologies. Yeah, this should be up here. Anyway, oh no, wait a sec. Well, this is a nightmare. No, keep going. Okay, right, better. So the injection type basically takes a type of, it takes two types. It takes an object of the target, and an object of the thing you're injecting to target, and it gives you a response. It gives you another version of the target with the object injected into it. Now, in this case, For us, because our things are all data classes, our HTTP messages are all data classes, it returns as a copy of the HTTP object, the HTTP message, basically. So we've got different types. So you can see there's some query of construction, and there's a body type as well, which we can use to kind of get out in and out, kind of also marshal JSON and XML and YAML responses, depending on the library that you import. In this case, we use Moshi. And the extraction type is the same thing, but basically in reverse. So you're taking a target and a type, and then you're going to extract an object of that type from the target object. So you've got the same thing here with like header.instant.required. So it's all typed, which is nice. So the lens system will automatically marshal the types in and out of the actual of the HTTP request or response in the correct format. So instance got like the ISO 8601 format. It does, numbers and, all the basic Java types, URL, all that kind of stuff. And you can extend it to add your own types. And we use the lens system across HP4k in all kinds of ways. We use it in HTTP requests and responses. We use it in environment keys, which you can see here. So we've got type safe environment. We use it in web forms. We use it in various other places. So you kind of see it all over the place. But the main thing to realize is that it's just function application. You can see you're applying the lens to either the type in the request or to the environment, or just the request to extract or put in that value. Okay, So that's what a lens is. And now what we're going to do, Ivan?
So should we apply that concept to these examples? So what we want to do is like have our own types for this response. For all these Pokemons that we're seeing as JSON, we want to automatically transform them to our own types and use that instead. So there's also another trick that we can do in this case.
So we're going to take the output. We're going to take the JSON format, which we had in, and we're going to go back to the toolbox again. And I'm going to have to go back into this again. Okay, so another thing that we created and we find really useful is basically to generate data classes from responses or from content. So we've got, as I kind of mentioned, we've got JSON, we've got XML, we've got YAML. There's lots of different like versions of these. There's Jackson and Moshi and Kotlin serialization, all that kind of stuff. And it's just, as with the rest of HP4k, a lot of it is just switch out your abstraction and the library changes basically by importing the module. But what we're going to do here is basically paste in our JSON. I'm going to hit generate. And lo and behold, down here, this is the representation of that. So it's named kind of slightly weirdly, but this effectively is the list, this data class base. And this result list, this result here is effectively the Pokemon because it's got a name and a URL. So let's take these classes.
Yeah, let's apply that.
And let's apply that back.
So we want to put that in our client. So in the Pokemon client, let's clean up and rename this thing. So this is clearly our Pokemon object.
Yep.
We don't need got a name, which is pretty much non-nullable, and we don't need the URL. And the results, we only care about the list of Pokemon really, so we can drop the rest. And don't need a question mark. So we have our basically the model that we get from the API. And what we're going to show now is how we can use that to, instead of returning the response for the list, we just want to actually return the list of Pokemon. So let's start a line, create a line after 13 and create a body lens there.
Yeah.
So val body lens probably.
So what I'm going to do here is I'm going to do a small tweak, which is called auto to automatically import because IntelliJ doesn't.
So these
guys, unfortunately, Okay. Perfect.
Yeah, so that's our lens. And we need to basically apply that lens to the response and we can get the results out. So let's get the response object out. So let's just extract that. So we have a clear, when we call the HTTP handler, what we get back is a response. And what we can do with that lens is just do body of the response, passing the response. And then let's do, that will return the results. Let's return the list directly. So if you do after the body, you do dot list, results. Yeah. So now our client returns, instead of a response, it returns an actual proper type, which is the list of Pokemons, which for sure has break-in compilation on the Pokemon 4k. So let's try to address that. So that right now, because it was just forwarding response, it means that we need to create our own response instead. So let's keep that list as a variable, maybe. Yeah. And let's create an OK response. Yeah, 200 with the body of results to string. It's fine. So like, again, it's not great, but we should see the difference now that our Pokemon 4k server, instead of returning JSON, it is returning the toString of our object. Yeah, which is probably not what we want as well. So I think we have to do something very similar now to return our list of Pokemon. So should we create our own data class for that? We need to create a data class. Let's call this data class Pokemon list, or yeah, and it has a val of Pokemons as a list of string. So we're just simplifying even more the API. Yeah.
Sorry. With an L.
Yeah, it's a list of string. Cool. And now, because we already have the result on line 24, or before or after that, we can create another lens now to inject our results into our response instead of extracting.
Wow.
Yeah. Oh, val.
Really wants to be that.
Yeah.
Body.auto.
Yeah.
Oh, let's do this. Import, and then it's what? Pokemon list.
Pokemon list. And as you can see, this is exactly the same way to create lens that we applied earlier. So if you go back there, so we have the body, and now because we already have the results and we have the lens and we have the response, so the only step missing is to apply the lens to the response. For injecting, we have a syntactic sugar that instead of doing .body, you do .width, and you say, I want the body of results, and this will get the lens. What?
Oh no, we haven't made it yet. We haven't made the
made?
object. We haven't made the Pokemon list.
Oh yes, sorry, forgot about the actual list. Yeah, Pokemon list of results .map.
Oh yeah, map.
Yeah,
it's name.
Should we extract that Pokemon list as like this is the actual list that we want to return?
So what we're doing here is we've got the results and we're mapping each of the Pokemon to its name, and we can reference it.
Should we run that?
Yeah, let's run it.
Yeah.
See what we get. Perfect.
Cool. So now we own the format that our Pokemon 4k will return. So if we want to apply any logic, if we want to make it look in different shape, we can just change the data class and things will automatically be changed. But what we really want with this is we want to add some functionality to Pokemon 4k. And this functionality is a way for clients to filter the Pokemon names and just get names that start with a particular prefix. So for that, what we need to do is add the concept of routing. We didn't talk about routing so far, and it is a key concept of HTTP4k, but like you saw, you can build a lot without that. But at some point, you need to figure out if I'm calling particular paths, I need to redirect that request to particular HTTP handler. So let's start by extracting our list Pokemon function from there. Yeah. So the list Pokemon that it is also an HTTP handler. Yeah. And we're only doing that to make it simpler to see that on line 23, we can add some routing now.
Okay. What do we want to route? What's it called?
So let's do, you can cut that for now, and then you can do root. Yeah, and we can do roots, and root support URI prefix. So let's do / in brackets prefix.
There you go.
Yeah, so that's your template, bind get request to that. Yeah. So that's enough to do some routing. So let's just run that again, maybe. And now we get 404. The reason we're getting 404 is because our main request on line 21 is not passing anything as a prefix. So let's do /b for now. So we want all the Pokemons that starts with that letter. And if we run, now it's finding our HTTP handler, but it's returning all of them. So we need to add some functionality there. So let's clean up a bit. On line 25, should we get the root and the list Pokemon and extract that as a function? Yeah, let's call that like... find all with prefix or something like that.
Okay,
that's fine.
There you go.
Yeah. And we can inline the list Pokemon because that's very simple now. Yeah, and let's move that to its own file. So we can add the functionality completely on that. Yeah.
So do that a sec. Well, hit copy. Let's move that as well.
Yeah, let's move the list there as well.
Oh, and then
Cool.
same again with the also, because
yeah, the imports when you move stuff in IntelliJ.
if only we knew somebody who worked for the company built.
Yeah, sometimes it creates a bit of a problem. Yeah, so we already have a routing now that you can pass a prefix. We do have all the data. We are already injecting that data. We just need to inject our bit of logic. For that, we need to first take the prefix out of the request, out of this path, and apply that as a filter in the list. So the way we do that, as we described earlier, is with lenses. So we need a different lens in this case, which we call prefix lens, and that's prefix path of prefix. Yeah, and that's the kind of lens that if you apply to a request, it will try to extract the value from the URI. So let's do that. The prefix equals prefix lens of the request. So prefix in that case will be whatever the client passed on that request. So with that, on line 22, we're doing the Pokemon list. We're mapping Pokemon name. After we map, we can actually use the prefix to filter. Yeah, dot filter. It starts with the prefix. Yeah, and I think we can run that again. Yeah, and now we have some functionality for find food prefix, and it actually filters based on the request. So as you can see, the find Pokemon with prefix is on its own is also an HTTP handler. So let's go back to we could put the type there, but it doesn't matter at this point.
It's a routing HTTP handler because it routes as well.
So going back to our main file, let's see what we got so far. So nothing much has changed on their main app. We still have our own server. We still take a client, and our own server adds a bit of functionality on top of some external API. So, but one thing that now we're still not talking to, well, we remember that earlier we replaced the real PokeCo API with the fake. So let's, just to make sure, let's replace back the fake Poke API with the real one again. And let's run one last time. And we get exactly the same results. And this time we're actually calling the third-party API, the Pokemon. And that, I think, is pretty much what we have. We could move the Pokemon 4k to its own file, but now it's just like mostly clean up. And I think that's mostly what we had in terms of demo, right, Dave?
So that's the main demo. So, and then we can, so the main thing, as we kind of mentioned, is like, the thing about HP4k is we're kind of a shim over various different runtimes. So what we've displayed right now is we've said you can run things in memory, which means it's not port bound, which means you can run all your tests in parallel, which means they're ultra fast. You can run it port bound using a static or a dynamic port, which also means you don't get port clashes when you run. And obviously, and that's great. And so that's really good as far as servers are concerned. But there is other things. So, for example, how do we take this and how do we put it on the internet?
Should we, before we do that, should we show that, like, we're going to share all the source code, by the way, but on the source code, we have a complete example.
Yes,
we do. If you open there.
Yeah, we do.
Yeah. So can you expand the project tab so we can actually see the files?
Yeah. Okay.
So if we go to the complete example, I mentioned at the beginning that we were not doing testing, for example, but here we can see all sorts of tests that we've done. And there are examples of how do you test a filter. And testing a filter, again, you just invoke the function, you use you can use an empty handler to do that kind of thing. And this shows that pretty much all the tests you can do for HP4k won't require you to run a server, won't require you to have a test runner, won't require you to have mocks because things are difficult to construct. So this is an example of tests we have. I think the find all with prefix is probably an interesting one as well. So like we mentioned, each endpoint can be tested in isolation, and you can basically have your application just this find all with prefix. You can construct just that endpoint, create that in memory, call with the request, make sure that it filters correctly. For example, if you want to add extra functionality, does it filter with case sensitive or not case sensitive? You can create a test for that, and all these tests will run just like unit tests because that's what they are. Another kind of test that we tend to do is the contract test. So contract tests, one thing that we didn't have time to show is that we created a fake, which it doesn't look great, just returns a response. It doesn't have any logic. And we do have the real thing that we want to integrate against. So it tends to be a challenge to make sure that we can provide a fake implementation that behaves more or less like the real one for testing. So contracts allow you to do that. So we show here, we have an example of the approach where we create an abstract test with the basic functionality that we expect the server to provide. And if you go down a bit, we have a fake Pokemon API test. And when we're dealing with fakes, because it's all in memory and we can control the environment a bit better, you can inject tests. We can inject failures. In this case, we can enable chaos behavior of adding latency, returning weird results sporadically, which is something that if you're integrating with a third-party API, it's really hard to do that kind of testing. But here, because you create this, you do have this abstraction in the middle, which is the HTTP handler, you can simulate and you can test the assumptions of how your application should behave, let's say, if the server starts returning a 500. And down we have the one against the real one, which, as you can see, is just injecting the real Poke code. Sorry,
so
Dave.
it's okay. Just a word on that, obviously. So because these two are just HTTP handlers, then they are completely interchangeable. The main logic of the main contract is in the superclass. So this is what we're saying about being portable, because you can take it and run it against anything. You could run it against a live server, not a problem, using one of the set base URL and filters to just on top of that would work as well. We have made some, in order to do, it's worth noting, in order to do the kind of chaotic stuff that you see here, we've slightly modified the fake Pokemon API to have a thing called a chaos engine, which is effectively a module for injecting chaos into any app, basically. So you can it's just a filter and it just sits over the top of another application. So you can just say, you can turn it on to say, return the status, you can add latency, you can make it eat the heap, you can just crash the entire process. All that stuff is kind of built in. Anyway, right.
Yeah, I think it's worth showing. Like, I think in Hello H4k in test, is that the one that has the main?
Yeah, I think so. Yeah.
Yeah. So normally what we tend is allow, because you have the fake, we see quite often teams will deploy that fake to a test environment, and you can actually connect your whole application using the fakes to simulate complex behavior, including chaos testing, which is quite an interesting approach, and you get almost for free with these HTTP handlers. I mentioned approval test as well, which is one exception that we do have our own test runner. We do extend JUnit for doing that, although approval tests allow you to have a way to do comparisons of complex responses from the server. So if you let's say your server returns a HTML page and you want to keep refactoring, making sure that you don't change the output, approval test is very good for that. You're going to get a file that gets written in the file system and you get in source control, and the test will fail if the response changes in any shape or form.
So one more thing. So we've got different versions of the various same tests here. So this is our unit test, which is sitting in memory. Then we've got the same thing with an approval test. So you can see the approval file, which is here, which is a cleaned up version of that. There's also, go back to this guy. There's also the server test, which is the port bound test. So all these tests are the same thing, but with slightly different contexts. Anyway, cool.
Yeah, these I encourage people to check out those examples, and you're going to see different ways of testing HTTP that you probably never saw before.
Exactly. Cool. Okay. Yeah. So let's talk serverless then, Okay,
Yes.
we've been going. Right, okay, so let's talk serverless. So the nice thing, okay, so serverless. So the nice thing about HP4k is that also because serverless is just another backend, what we can do is actually just apply a very small adapter and actually then deploy our applications completely onto AWS Lambda with no modification at all. So you can see here, what we've done is the Pokemon4k. If we want to put this thing into API gateway, all we do is basically we have to extend a class because that's what you do in AWS Lambda, which is we've decided to API version gateway 1, and this is our application. Our application is completely unchanged. We're using Pulumi to deploy it. Pulumi, if anyone hasn't used it, is really nice. It's a kind of way of, it's maybe similar to Terraform, where you kind of can deploy resources, but it's all in code as infrastructure kind of thing. It's really, really good. We would really recommend it. But let's see how this looks on the internet. So we've deployed this. Okay, go on.
So with that proxy means that you deploy your HTTP handler and it creates a API gateway, which is a proxy to your whole application, meaning that it can handle all methods and all paths that you send across. So it's not a full API gateway as you would do, let's say, with Kotlin, which will create the API gateway, which for each endpoint. This is basically using API gateway as a proxy, which is the simplest way that we found to actually have HTTP behavior on AWS.
So it means also that obviously you can test your entire app or run your entire app locally and then just deploy it and you get exactly the same behavior, which is brilliant. Right, yeah. So let's go and see what happens when we go and do that. So we've put that onto, so this is the deployed version of our thing. And this is where we find out why Java's got a cold start, because it takes a bit of time to get going. And here it is. This is the same code running on the internet. And if we go to, we can see the Lambda. If we go to the list of Lambdas, we can see we have our standard HTTP4k, AWS version. It's a Java 11 Coreto, and it's 5.4 meg. So the nice thing about HTTP4k as well, because it's really small, all of the binaries are really small as well. So that the binary size has also an effect on startup. But more exciting than that, I think, is growl. So with growl, we have exactly the same thing. What we've done is written a custom HTTP4k runtime for growl. And the AWS runtimes work slightly differently. So what we actually do is, instead of creating this Lambda, which we extend from a function, what we actually do is create a mainable. So that main, and once again, we've got our same Pokemon4k API, and we've got an adapter, which we've written, and then we turn it exactly as we did with the port-bound stuff on locally into a runtime, and we start it. This application is then compiled into native by growl VM using the incredibly slow growl deployment process. And then because we don't use any reflection, and because we're using HP4k uses Moshi without reflection for events and all that kind of stuff, it just runs with zero modification and zero reflection config, which is a real problem with the kind of growl-based stuff. Once again, we're also using Pulumi to deploy it. You can see here that when we did it, this is the kind of how long it took to deploy it. It took 100 milliseconds, 100 seconds in order to build the thing, which is obviously, but exactly the same thing as before. We've got a URL, and that becomes this growl VM image. Let's run growl VM. This is growl. We can see that's much faster, and we can see just how fast it is again if we run it again and again. If we go to CloudWatch logs, we'll be able to see how long it took to run. That's not okay. So let's go to AWS. Let's go to 551. Yeah, it's this one. So you can see okay, I'll do both, but okay, this one. Okay, this is that's the wrong thing. Sorry, apologies. It is wrong log group. It's this one. Did I pick the first one before? This one, isn't it? Yeah. Here we go. We can say that this one, so the initial image took 3 seconds, of which, so 3 seconds of which the init duration was 1 second, and it used 119 meg of 128. It's actually timed out because I've got the wrong config. Damn. Okay, but if
that's not the one from today.
Oh, is it? Okay. Oh, okay. Okay. I'll tell you what we do then. Let's test it with a proxy call, and we can see just how much faster it is. So this is what this is the JSON that actually goes to the endpoint. So what happens is that Amazon turn the HTTP request into JSON, and then we test it. So you can see here, yeah. So this is 200. So this is 550 more milliseconds. This is a warm start, but it took 154 milliseconds. And the poke of that 574 milliseconds, 508 milliseconds of it was the Pococo API, because we added a little bit of debug in there. If we do the same thing with the growl one, we should see a much nicer response time. Sorry, not intending to have to write this in, but live demos, eh?
Yeah.
Okay, so that took non-cold start. Oh no, that is a cold start, I think. That was 157 milliseconds with 80 meg render used, basically. Yeah. Same request, same response. Let's try again and again.
Way less memory.
Way less memory. So obviously, yeah. So the thing with Lambda, for Lambda calls, you are paying a multiplication of the build duration and the memory size. So you can actually make things faster, but by increasing the memory size. But then at the same time, you're actually increasing your costs. So if you've got, especially the nice thing about this is because it's got zero configuration because of the way we're building it. We've got a custom Docker image that we use to just build the growl stuff. But we keep running it again. You'll probably see, yeah, it's kind of 38 milliseconds, 25, 29, 30. And you see the JVM kind of optimizing. Okay, cool. So it's
there's some slides on there, right?
That's the slides, yeah. So yeah, I suppose the thing on that was the slides. So there was one more slide. Oh yeah. So actually, what I didn't do was this. This is how the growl image is built. So basically, you've got the runtime, which we built ourselves, which is the HTTP4k. You've got your app that you'll build that builds into a shadow jar. All those three things with Linux, the shadow jar, and the image go into Docker. It churns around and it churns out a native image, which you then can just, as a zip file, that you can then just upload to AWS. These are the serverless types. We won't kind of spend too much time going over them, but the main thing is that we support both HTTP and event-based kind of programming. All of it, none of it uses reflection, so it will work with growl out the box, no problems. And the handler, filter, loader kind of concepts are that you'll find those are consistently applied throughout HTTP4k, regardless of what we do. If we do HTTP, we do functions, we do server-side events and WebSockets. It's all the same abstractions. So if you learn one, then it's really easy to kind of apply that to the others. Ivan, what's next? We got any more time?
I think we have a couple of minutes to show one last, we have two more things that we couldn't show, but people can check them out in the code. I think we can just do a quick run through the OAuth example. And then the two extra things that we show is first, how would you add security on top of an HTTP4k application? So if you go to the main there, Pokemon 4k. So another thing that we found that was relatively easy to add on top of those concepts and just using more filters and basic data classes is how you can make your application be a provider for OAuth. So in this example, we're going to get the same. So we still have the find all with prefix on line 42. So it's the same thing there. But what we're going to do is we're going to protect that using OAuth. So for that, on line 25 and 26, we use those are lenses to extract things from environment variable. Like we described, those we can pull things from environment variable in a type-safe manner using lens. And we have out of the box some provider definitions, which are basically the definitions of what are the usual URLs to authenticate, what kind of callback the different services use. So in this case, we're using OAuth Provider GitHub to define what's the configuration that we need if we want to use GitHub as our authentication method for our application. And once you create that provider, then you only have to define one extra endpoint, which is your OAuth callback that you can see on line 41. And that OAuth callback is, we basically provide an endpoint that will do all the exchange of tokens, and you have hooks to put your own validation and storage and things like that. But you add your endpoint, your callback to an endpoint there, configure that in your service, and then the provider itself becomes a filter. The OAuth Provider.auth filter you can apply to whatever resource you want to protect. So in this case, we got our excellent find all with prefix, and that can only be accessed now by GitHub users after we add this change. Do you think you have time to do a quick run on that?
I think I can run it. Yeah. Okay. So once again, it's undertow. It just starts. It's nice.
Yeah.
So let's go. So we're going to go to OAuth. So this is going to take me. So that's gone to the local. It's gone to the local local host, and we've configured. We've created Hello HP4k as an OAuth application inside GitHub, and we're basically redirecting back to that. So if we authorize it, you can see we can draw it back, and we've been authorized. So we've now got a session with us. We've got a GitHub token, and we can use that on as we see fit. Cool.
Yeah. Cool. I think we have one last example. I don't know if we can just run that.
Yeah, go on. Why not? Let's do it.
Let's just run that. This one is slightly more complicated, but we didn't show how HP4k can be used to like more front-end like development. But we do have quite a few modules that are targeted for this kind of application. And we have an example using Hotwire, which I think is a good demonstration of various things, including server-side events, and turbo links and templates. So we're not going to have time to go through the code. So the code will be available for people to check it out. But I think we can run that at least to show like what kind of thing you can get just by building on top of the things that we demonstrate today.
Okay, so it's running. Okay, so, and where is it? Hotwire. There we go. Right, cool.
Yeah. So this beautiful page is a handlebar template that we put. And that time via server-side events is something that is pushing time for the client. The client is updating the UI every second. And we did how you can load your next Pokemon using turbo streams. So every time you click find next there, you are going to the server, pulling a bit of HTML on the fly and injecting that to the DOM using JavaScript. So the example that has all the bits that are required to do that, all the template configuration and all the specific things for you to run both server-side events and server-side events and a normal HTTP handler on the same server, for example. This is on the demo, so we do encourage people to go and check it out and ask questions if they have any trouble running or understanding it.
Yeah.
Cool. I think we are
okay. We're almost done. I think, yeah. So I think we've got what, one more slide? Yeah. So
yes.
That's it. The end. Thank you. Brilliant.
Perfect. That was nice. Really nice demo, folks. And we do have some questions, not as many as I expected. But I think those that I've got for you, they're basically predictable. If you talk about micro frameworks, I think it's the usual question about the modules, what is supported out of the box, if you provide any modules available. And one of the questions was about support for service discovery, if there is any Erica or console integration provided by you.
That's something we haven't actually we haven't come across, but we have actually done. We have done service discovery on projects where we've used HP4k. We've never done. It's never actually made it into the library. But it's quite easy to do, because that's, I think, the thing we've found a lot with all of this stuff is by keeping things simple, by keeping everything quite compact, it's kind of trivial to plug in your own technology, whatever it is. I mean, talk to Vault, to, security models or etc. Or service discovery. It's all doable. There's nothing complicated that's going to trip you up by going, oh, I've got this thing that's not documented. It's just all there to see.
That's my understanding as well. Like, you get the library and just use the library for discovering the service. Why
and if
why complicate things?
if people check out the source code, they'll see that it's quite, because everything is already so modular in HTTP4k. Adding a module for console, for example, will be very simple. Will probably be a few dozen lines of code, and we're happy to take the contribution. If people want to have a play with it, come and talk to us.
Module as a function. All right. And the other one, which is also kind of expected, about the coroutines.
I'll leave that to Dave.
if coroutines are supported.
Well, at the moment they're not. We'd actually do it to see the model. We had a play to see if it was, but at the moment we have not. At the moment, I think there was one of the interesting things was that coroutines actually isn't supported properly by the type system. In that, and this surprises people, that you can't extend a suspend function. So we would have had to change our model, and apparently that is being fixed, I believe, in 1.5.20, I think, which is now in. So we thought we'd take a look at that potentially again. To be blatantly honest, we've found limited uses for coroutines. Coroutines below the hood, structured currency, it's amazing, brilliant. For the actual server side serving, especially when it comes to a lot of our work now is in serverless, and serverless is actually completely the opposite of concurrency because you're doing one thing at a time, ever. Mm-hmm. So it's that question of, it's a balance of complexity over simplicity and the small modular size. As soon as we rely on coroutines, then we're going to basically have to rely on the coroutines library, and that's a few more meg. It's so everything kind of there are lots and lots of different.
We also watching out for Loom, right?
Definitely, Loom we think will be an interesting one as well. So we think that's going to be interesting for everyone concerned. But yeah, so that's our diplomatic answer on that.
Cool. So that serverless example, did you guys try to implement all your projects with the growl VM now, or like how do you compare the two approaches for deployment?
I think for deployment, my current project is all serverless Kotlin, and it's quite high volume. So it's really just that warm start, really, that I think that is the real problem. And I think there have been some quite interesting studies about size of binary versus cold start. If you look at a lot of the kind of JavaScript libraries that get pulled in, it's great for a hello world, but by this time, because JavaScript is obviously quite heavy on node modules and like everything, it doesn't take long for. I think the last JavaScript Lambda that I looked at was actually the binary was 50 meg. So everything isn't as it seems. I think there's a lot of work to do with, and it'll be interesting, especially with the Loom thing, especially with. Growl is at the moment, I think, there's that tension between it taking. We saw it took 100 seconds to build it. The complexity of not deploying but configuring it is considerable, and that's, I think, where people will get stuck. We tend to shy away very heavily from anything involving reflection. For instance, Jackson uses reflection heavily. That's where we use Moshi, and we use adapters that have been the growl module itself is still using also lens bodies, but it's actually using also lens bodies that have been built. Actually, the adapters have been generated by a thing called Kochi at compile time, so you get no reflection. So once you get no reflection, you're totally fine. The minute you start to have reflection, you need to start acting reflection config, and it just becomes. It can become a challenge and not a particularly pleasant challenge.
I think the main takeaway from is that we don't want that to be too much disruption in the developer experience. You can still focus on writing your HTTP handlers and your functions. And if you're going to deploy with growl, or if you're going to deploy with straight AWS, or if you're just going to run as your own server using Undertow, it shouldn't make tons of difference to your HTTP server.
I see. So one last question. How would the folks find the source code of the demo?
Right, yes. It's it will be as soon as I come off this call and make the repo public. It will be public, and it will be in HP4k. We'll post the link. The link isn't here, but we can put it on anywhere. But it'll be one of the.
And we will post it to the comments to the video.
Yeah,
yeah, it's gonna be in the description.
Yeah, it will.
Nice. So it's the end of the session. All the folks who were online with us, great. If you haven't subscribed to the channel yet, subscribe, hit that bell. You know, like the phrase I wanted to tell all my life. But thank you, David. Thank you, Ivan, for joining us today. And it was a nice session. And have a nice one.
Yeah, thank you for having us.
Bye.
Bye.